Welcome, dear students. Today we are going to discuss the lab program number 16, part B lab program number 16. So that is to display the hexadecimal digits from 0 to F on a 7 segment display with appropriate delay. So I have already explained in one of my recorded video lecture while explaining the sensors and actuators the 7 segment display. So it's called 7 segment display because it has 8 LEDs. There are two ways of connecting these 8 LEDs. You can connect all the cathodes of the LEDs together. It's called as common cathode, and similarly the other way of connecting all the 7 LED segments is by connecting the anode terminals. It's called as common anode. Now here we will be using the common cathode. So that means you have all the cathode terminals. LED has two terminals. One is the cathode terminal, another one is the anode terminal. We are going to connect, we are using the common cathode 7 segment display because all the cathodes are connected to commonly, and it's connected to the ground, and we have the anode terminals to which we'll be supplying the high voltage in order to eliminate the LED. So we'll understand this program for today with the program explanation and the simulation of the same. Now this is what in the picture what you're seeing is the 7 segment display. So you have 7 segments are there. So this is one segment. This is called as segment A. This is called as segment B. This is C, D, E, F, and this is G. These are the 7 segments, and in addition to this 7 segment there is one more segment. So that is the decimal point dot. It's called as DP, decimal point. Including this totally there are 8 segments, but generally this is called as 7 segment display, and these segments are named like this: A, B, in the clockwise direction you have to come, A, B, C, D, E, F, and G. And the schematic diagram of the LED, it is written here. Now this is how the LED, light emitting diode, looks. It has two terminals. One is the cathode terminal, another one is the anode terminal. Now 7 segment display types, as already told, there are 2 types. One is common cathode and another one is common anode. Now the example what you are seeing here in the picture is of type common cathode, because you can see the cathode terminals of all the LEDs are commonly connected to the ground, and you have the anodes open here, and this is the schematic, and this is how the 7 segment display looks like. So this is the anode terminal A, this is the anode terminal B. So this is the anode terminal of this particular LED segment, and this is the anode terminal of this particular LED segment, and C is the anode terminal of this particular segment, and D, this pin what you're seeing here is the anode terminal of this, and this pin is the anode terminal of E, and this pin is the anode terminal of F, and this pin is the anode terminal of G, and this what you're seeing is the cathode terminals of all this LED connected together, and that will be connected to the ground. So this is what, and here you can go through the common cathode. So in common cathode display, all the cathodes connections of the LED segment are joined together to logic 0 or ground. That is what I'm showing. You can all the cathode terminals here are connected together, and they are connected to ground or logic 0. The individual segments are eliminated. Say if you want to eliminate this particular, I want to eliminate the segment A, I have to apply logic 1 to this. That is what we do in common cathode. Now all the common cathode terminals of the 7 segment is connected together and connected to the ground or to the logic 0, and if you want to make any of the segment glow, the corresponding anode terminal must be given an I logic. And similarly the other type is common anode. You can observe here the anode terminals of all the LEDs are connected together commonly, and it's given to the plus voltage. Now here, this is the common anode. So this terminal is connected to plus voltage. That means you have to give the positive voltage supply here, and all this, you have to supply the zero logic, if you want to make any of the LED glow. Since this is already connected to the positive supply, if you want to make any of the LED glow in common anode mode, so you have to apply the logic 0. That is what is written here. Now all the anode terminals of the LED segments are joined together to logic 1. It's connected to plus voltage, and individual segments are eliminated by applying logic 0 or low. So if I want to make this particular LED here glow, I need to apply the logic 0 here, because this is already connected to the plus voltage. So this is what the common anode, and in our lab experiments we will be using a 7 segment display, which is a common cathode. Now for displaying the codes for the common cathode in 7 segment display, common cathode 7 segment display. Now how I need to write the codes. Say for example, I want to display 0 in the 7 segment, and 0 in the 7 segment looks like this. I want the segment A to be on, B to be on, C to be on, D to be on, E to be on, and F to be on. I'm saying we are using a common cathode 7 segment. Now what is the data related to that? So this is what the data. So I going to write all the segments from A to DP in the right to left order, like this: A, B, C, D, E, F, G, and then DP. So don't write in this order from left to right. Always write it from right to left, because A must be the least significant bit and DP must be the most significant bit always. Now for displaying, for getting 0 on the common cathode 7 segment, now I want LED A to be glowing. For on common cathode, for A to make glow, now I have to give the value 1. So if I give here to the anode terminal of this particular LED, A will glow, and similarly B should also glow, that is 1, C should also glow 1, and D should also glow 1, and then E should also glow 1, and F should also glow 1, and G is this. I don't want this particular LED to glow, we are giving the logic 0. Now and DP, always I make it as 0. I don't want DP to glow any point of time. DP is made as 0. Now what is the data corresponding to this hexadecimal equivalent of this? Now this 0, 0, the one which you are seeing in the red, 0, 0, 1, 1 is 3. That is the X code which I have written here, 3, and 1, 1, 1, 1 which you are seeing in the blue is F. 3F is the data which I need to give on the port pins to which the LED segment, this common cathode LED, is connected in order to make it display 0. This is my data. And similarly, to display the data 1, now which are the segments to be glowing? B and C. Either you can make B and C to glow, or the F and E to glow. So I am making here B and C to glow. Now for these to be glowing, these two to be glowing, I want to make B as 1 and C as 1, and the rest all is 0. Now when I write the hexadecimal equivalent of this binary number, so this is 0, I got 0, and this is 6. Now I have to apply the data 0, 6 to the port pins of the microcontroller to which the LED, common cathode LED segment, is connected in order to get the digit 1 in the 7 segment display, common cathode 7 segment display. And similarly to get B, so get 2, this is what 2 you are saying, to get this 2, so I want A to be glowing, B to be glowing, G, E and D to be glowing, and the rest all should off. Now A should be on, see 1 is on, and B should be on, and C is not glowing, it is 0, and D should be glowing 1, E should be glowing 1, and we don't want F to be glowing, it is made as 0, and we want G to be glowing, G is made as 1. So now the data corresponding to this in hexadecimal is, this is 0, 1, 0, 1 is 5, and this is 0, 1, 1, 1, 0, 1, 1 is B. So these are this is how you got to compute the X code for the digit which you want to display on the common cathode 7 segment. If you want to do it on the common anode 7 segment display, so then it is opposite. Now for common anode, in order to make a particular LED segment glow, you got to give the data as 0. You have to make that particular port pin as 0. Here only, if I want to display 0 on the common anode 7 segment display, these two will become 1. This is 1, this is 1, and the rest all will become 0. It is opposite. Now since we are using common cathode 7 segment, we'll focus on that common cathode 7 segment display. Now similarly, so for displaying 3, these are the LEDs that should be glowing. Wherever 1 is there, I want all those LED segments to be glowing, and the data what I got is 4F. And similarly for displaying 4, this is. Now because see, I don't want A to be glowing, it is 0. I don't want D to be glowing, it is 0. And I don't want DP, that decimal point, to be glowing, and it is also made as 0. So like this, I'm computing the X code similarly for all the bits, because I want to display from 0 to F. So 0 to F, and this is 66 is the X code for displaying the digit 4 on the common cathode 7 segment display, and 6D is the X code for displaying 5 on the common cathode 7 segment display. Similarly like this, for displaying 8, it is 7F. You can observe here, for 8 all the 7 segments must be glowing except this DP. So DP is 0. Now I have or the rest all glowing. This is nothing but 7. So 0 1 1 1 is 7, and this is 1 1 1 is F. And similarly for displaying 9, 9 you can display like this, and I'm glowing this particular relay segment also, A, B, C, D also I'm making it to glow. Sometimes D, some people will not make it to glow, they'll make it as 0. Now this is fine. 6F, and then A, because I want to display from 0 to F. After 9 it is A. And then B, for B I'm using the lowercase b, because if I make it as uppercase B, it will not be possible for you to distinguish between 8 and B. So that is the reason B is displayed as lowercase, and C uppercase. This is the X code, and D 5E. Again D I'm again not displaying in the uppercase, because if I display D in uppercase, it's not possible for you to distinguish between D and 0. So D in lowercase, and E again in uppercase, and F in again in uppercase. These are the X codes. This is what you have to compute when you want to display something on a common cathode display. First you got to write the X codes for displaying the equivalent digit on the cathode, common cathode 7 segment. So now with this you understood now how to write the X codes in order to display the appropriate digit on the common cathode 7 segment display. So next is understanding the 7 segment and LPC214 8 port pins used. Now what kind of 7 segment display we are using in our experiment? We are not using just one 7 segment display. Instead we'll be using 4 7 segment displays like this. Now this 7 segment display is a common cathode 7 segment display. That means all the cathode terminals are connected together and connected to the ground, and if you want to make any of the LED glow here, you have to apply a logic 1 to the anode terminals. So you can see here A, B, C, D, E, F, G, H. These are the anode terminals, and so all the cathode terminals of this particular 7 segment display are connected together, and that is 1. 1 corresponds to the common cathode terminal of this particular 7 segment display, and 2 here corresponds to all the cathode terminals of the second 7 segment display are connected together, and it is this pin 2, and all the cathode terminals here connected together, and it is this pin 3, and all the cathode terminals are connected together, and this pin is 4. Now so this is what we use. And why 4 7 segment displays are there in one device? Because say I want to count up to 4 digit. Now using this I can count up to 999. Now you can count till there. Now if you want to count only till 10, then only 2 segments are required, because 0 1 up to 10 is 1 0. And similarly if you want to count till 999, then you require 3 segments. So we have here 4 7 segment displays we are using, and each of this is a common anode type, common cathode type. So next, so this is what the 7 segment display which we use, and this is a common cathode 7 segment display. Now if I want to make say for example, now I want to make this particular LED, I want to display only here. What is that I have to do? I have to give logic 0 to this, logic 0 to this, and logic I to all the remaining 3. Then only this is active. Why? Because this all the cathode terminals are connected together and it is connected to ground. Now if I apply logic 0 to this one pin, you have this logic particular 7 segment is on, and this is selected, and this will go for displaying whatever you send the data through this A to DP. And similarly, if I make this particular on, bit on, so then this is selected, this is not selected, this is not selected, this second one is selected. Similarly, if I connect this to 0, 3 to 0, this is selected. If I connect 4 to 0, this is selected. Now if I want to select all of them, I have to give 0 0 0 here. If I make this also 0, this also 0, this also 0, this also 0, all 4 will be selected, and whatever the data you give here, the same thing will be displayed on all the 7 segment displays. So this is what the 7 segment display which we'll be using. So common cathode 7 segment display, but you don't have one 7 segment display, instead it has 4 7 segment displays. Next, to understand what port pins are used to send the data to the 7 segment displays, you got to send 8 datas. Now these are the port pins which are used, P0.16 to P0.23. Now you can use any other ports, but I'm using this port pins only because in the ALS kit, so the 7 segment display, it's connected, A, B, C, D, E, F, G and DP of the 7 segment display in the ALS kits, they are already connected to P0.16 to P0.23. Now you can count from P0.16 to 0.23, totally 8 pins are there to send the data, including DP, so totally 8 pins. And similarly, port pins used to select the required 7 segment. I told there are 7 segments. Now you can select, say I want to display on only one 7 segment, I can go for selecting one 7 segment. I want to display on all the 4, I can go for selecting all the 4, like this. To do that, to select the required 7 segment display, again the port pins used are P0.31 to P0.28. Now and again you have to use P0.28 to 0.31 only, because in ALS kit, in simulation you can change whatever to any pin, but ALS kit, since it's already permanently connected, these are the port pins used. Total of 4 pins. Now this is how it is connected. You can observe here, this is a 7 segment display, numbered, labeled from A to dot. So this is, sometimes we call it as dot, and sometimes you can also call it as DP. Now segment A is connected to P0.16, B is connected to, segment B is connected to port pin 0.17, and similarly G is connected to P0.22, and dot is connected to 0.23. And now the 4 the select lines, this P0.28 to 0.31, they act as a select line in order to select the 7 segment displays. Now so I want to select the first 7 segment display. Now I should be making P0.28 as 0, and second 7 segment display I should be making P0.29 as 0. So third P0.30 as 0, and fourth, if I want to use P0.31 as the 0. If I'm making all of them as 0, so the data what you send, it will be displayed on all the 7 segment displays. So these are the port pins which you got to remember for understanding this program. So we are sending the data from P0.16 to P0.23, and we are using P0.28 to 0.31 for selecting the required 7 segment display for displaying the data. Now here I'm showing you to select the first 7 segment display. Now I want to display only on this. You can see the picture here. So I want to display only on the first 7 segment display. To display the data on the first 7 segment display, what is the data I have to apply? I have to apply this data 0s, because I want to make only P0.28 to be active, because I have this particular this one, I'm connecting it, you can observe here. So this one corresponds to this. That means all the cathode terminals of this 7 segment display LED terminals are connected to this one, and this one should be grounded. So observe now. Now one, I'm not connecting it to ground directly here. This one, I've connected to the output of the NOT gate, and this input of the NOT gate, it is coming from P0.28. That means this particular segment, it's connected to P0.28. And what is the data I'm giving? I'm giving the data. Red means 1. So this 1 will be converted into 0. I'm applying 0 to this. So why can't I apply 0 directly to this? You can apply 0 directly to this because in the ALS kit it is designed like this. So 1 indicates selecting. In that way, it is taken because if I give 0 here, it doesn't look nice. Now 1 says I am selecting what if I make P0.28 as 1, I'm selecting the first LED segment. So in that convention it is taken, but NOT gates are there which will convert it into low. Now at the moment it is made as low, this is active and all other are disabled because they are high. Now this is what I have to do. What is the data I have to apply in order to select only this particular 7 segment display to display my data 0, 0, 0, 1, and it is in this order. See this 0 P0.31 is connected to 0 and that is low. So this is all these 3 are low. You can observe here all these 3 are low. Then low here are getting converted to high and this is high. That means these things are not active and only this thing is active because 1 is the data which I'm outing from P0.28 and this one is converting it into 0 here and you have only this, and now the data is getting displayed over here. You can observe this data also here. Now so red means on, so this is A, so A is on. Next one is B is also on. Now which segment is off? G and DP. This is G because it is 0 and DP is this decimal point which you are seeing here, that is also off. It goes like this. Now if you want to select only the 7 segment display, first 7 segment display, apply the data 0001, that in decimal hexadecimal is 1 to this. And similarly to select only the second 7 segment display segment, apply the data, sorry, this is not 00020, it is 000, yeah, 00010. So 10, so 00010, that means P0 point, it is in this order. Now P0.28 is connected to 0. The data which is coming out of P0.28 is 0 and the data that is coming out of P0.29, so this is P0.28 again, P0 point, save, P0 point, the data that is coming out of P0.28 is 0, so this is 0. See here, P0.28 is this, the data that is coming out of P0.28, this is 0. So this 0 is converting it to 1 and this is 1 right now. That means this is not active. And from which port pin the data 1 is coming out? P0.29, the next bit. This is P0.29. Now from that you have the data 1 coming out and this 1 is getting converted into 0 and you have the second one selected, and from the remaining 2 you have the data 1 coming and they are not selected. Now if you want to display the data only in the second 7 segment display, you got to apply the data 0010 or 2 in hexadecimal. This is nothing but 2. And similarly, now if you want to display only the third, display on only the third 7 segment display, what are the data you got to apply? This 4 you have to apply. 4, it will make the port pin 0.30 to emit the value 1. So see, P0.30, this is connected to P0.30 and what data it is emitting out? 1, and that get converted into 0 because of the NOT gate, and this is 0, third one is 0, that means this is selected and the rest all are not selected. Now to select the fourth one, similarly the data is 8 because this now you are outing I value from P0.31 and that gets converted into 0 and the rest all remains in 111. So zeros are converted into 111. So we don't have the first 3 active, we have only the last one active. Now what if I want to display the data on all the 7 segment display? Now what is that I have to do? I have to apply, I need to select all the 7 segment display. I have to give 111, I have to out 111 from P0.28, again this is 0.28, from P0.28 to P0.31. So this is also P0.28 in the previous slide. So this is also P0.28. Yeah. Now if you want to display the data on all the 7 segment displays, the data that you should be outing is 1111. If you're not using the NOT gates, so you have to, and I want to select all the 7 segment displays and I'm not using the NOT gates, then you have to use what? Directly send 0 0 instead of 111, you have to send 0 0 0. Now this is the program. Now first let me explain this program. Now as usual, lpc2148.h header file. Now you have a global variable delay and count initialized to 0 and switch count is also 0, and this is what my array display of 16. Now what I have written, this is the X code for displaying 0 on 7 segment. So 3F, that is what I showed you here. How you got 3F here from here. So this is what the X code. If I want to print, if I want to display 0 on the 7 segment, I have to send the data 3F via the port pin 0.16 to 0.23. That is what we are doing. So why I have written 3F here only? Because this is 32-bit number. 3F should be written here only because this comes to the position 0.16 to 0.23. So this is from 0.0 to 0.3. This is from 0.4 to 7. This is from 0.8 to 0.11. This is from 0.12 to 0.15, and this is from 0.16 to 0.23. 0.23. It should be in this position only. And similarly, this is the X code for displaying, printing or displaying 1 on the 7 segment display. Similarly, this is the X code. Just we have already computed 5B. X code for printing 3 on the 7 segment display. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Nothing but 15. Now let me start from